In the realm of object-oriented analysis and design, use case modeling stands as a titan, a methodology that effectively gathers requirements and structures interactions between users and systems. This approach, deeply rooted in the Unified Modeling Language, or UML, provides a window into the system's behavior as perceived by its end users, stakeholders, and other external systems. What sets use case modeling apart is its focus on what the system does from the user's perspective, rather than how it does it. This perspective aids in comprehending the functional requirements of a system. Now let's dive into the integral components of use case modeling. We have actors, which represent roles that interact with the system. We have use cases, which describe a sequence of actions delivering measurable value to an actor. Then we have the system boundary, defining the scope of the system. And finally, relationships that tie all these elements together. Understanding these components and their interplay is key to effective use case modeling. Actors, the first component of use case modeling, symbolize roles that interact with the system. They are the lifeblood of our models, providing the context we need to understand the interactions and requirements of our system. Now, these actors aren't Hollywood stars, but they are just as important in their own way. They can be users, other systems, or even hardware devices. Basically, they are anything or anyone that interacts with the system we're analyzing. Actors come in two flavors, primary and secondary. Primary actors are the ones who initiate interactions with the system. They're the ones who start the ball rolling, so to speak. For example, in an online shopping platform, a customer who places an order is a primary actor. Secondary actors, on the other hand, provide services to the system. They are the supporting cast, making sure everything runs smoothly behind the scenes. An example of a secondary actor might be a payment gateway that processes transactions for the online shopping platform. Remember, actors are external to the system we're modeling. They help us define the boundaries of our system and understand the different roles that interact with it. So, whether it's a user placing an order, an administrator managing user accounts, or a payment gateway processing transactions, recognizing and defining actors is the first step in use case modeling. Use cases provide the backbone for our use case model, describing the sequence of actions that deliver measurable value to an actor. Let's take a closer look at the lifeblood of use case modeling, the use cases. So what exactly are they? In a nutshell, use cases are the different ways that an actor interacts with our system. They are the stories that detail the step-by-step sequence of interactions that an actor follows to achieve a goal. Each use case is a complete series of events, described from the point of view of the actor. The importance of use cases cannot be overstated. They help us understand what our system is supposed to do from the user's perspective. They allow us to visualize the functional requirements of the system, focusing on what the system does, not how it does it. Let's illustrate this with a few examples. Suppose we're creating an online shopping platform. Some potential use cases might be login to account, browse products, add product to cart, checkout, submit payment, and track order. Each of these represents a unique interaction between an actor, such as a customer or an administrator, and the system. In the context of a banking system, use cases might include open account, deposit money, withdraw money, transfer funds, or check balance. Remember, use cases are all about understanding the system from the actor's perspective. It's about answering the question, what can the user do with the system? Identifying use cases is fundamental to understanding system functionality from the actor's perspective. The system boundary delineates the system's scope, while relationships interconnect use cases and actors. Now, let's delve into these concepts. The system boundary is akin to a fence that surrounds the system, defining its scope. It encompasses all the use cases that are part of the system and separates them from the actors that are external to it. This boundary can be visualized as a box in a use case diagram, with all the use cases inside and the actors outside. For example, in an online shopping platform, the system boundary could include use cases like add item to cart, checkout, and track order, while excluding actors like customer, payment gateway, and delivery service. Now, let's talk about relationships. They create a network of interactions between use cases and actors. Relationships can be of three main types: include, extend, and generalization. Include is like a shortcut. It indicates that a use case contains the behavior of another use case. This is useful when several use cases share common behaviors. For instance, in a banking system, the use case transfer money might include the behavior of authenticate user. Extend is a bit like a bonus feature. It represents optional behavior that can extend the behavior of a use case under specific conditions. For example, apply discount could extend checkout if the customer has a valid discount code. Lastly, generalization is essentially inheritance. It shows a parent-child relationship among actors or use cases where one actor or use case inherits the characteristics of another. For instance, premium customer could be a generalization of customer, inheriting all its characteristics but with some additional features. In a nutshell, the system boundary confines the system, marking a clear distinction between what's within the system and what's outside it. Meanwhile, relationships weave a web of interactions, reflecting how use cases and actors are interlinked within the system. Defining the system boundary and determining relationships helps to structure the interactions in the system. So understanding these concepts is crucial for effective use case modeling. Now that we understand the components of use case modeling, let's explore the steps involved in creating a use case model. First, we start by identifying the actors. These are the roles that interact with the system. They could be direct users, other systems, or even hardware devices. For instance, in an online shopping platform, actors might include the customer, the administrator, or the payment gateway. Next, we identify the use cases. These represent the system's main functionalities as seen by the actors. They describe the sequence of actions that deliver a measurable value to an actor. For example, logging into an account or processing a payment could be potential use cases. The third step is to define scenarios for each use case. These scenarios detail the normal course of events as well as alternative paths, providing a step-by-step account of how the system and the actor interact. Then we determine the relationships between use cases and actors. These relationships can be of different types, such as include, extend, or generalization. For instance, a login to account use case might include a check user credentials use case. The fifth step sees us drawing the use case diagram. This visual representation helps to illustrate actors, use cases, and their relationships. It's a kind of visual shorthand that helps stakeholders understand the system's behavior. Finally, we write the use case specifications. Each use case is documented with a name, the actors involved, preconditions, postconditions, the main flow, and extensions. This documentation serves as a detailed guide to the use case, providing all the necessary information in one place. In essence, use case modeling is a process of identifying, analyzing, and documenting the key interactions between users and the system. It's a methodical approach that helps ensure all the functional requirements are captured and understood. These steps provide a roadmap for creating a comprehensive use case model. Use case modeling, a powerful tool in object-oriented analysis and design, relies heavily on the understanding of its components and the process of building a use case model. It's a method that gives us a user-centric perspective of system functionality, focusing on what the system does rather than how it does it. The key components of use case modeling include actors, use cases, system boundary, and relationships. Actors could be users, other systems, or hardware devices that interact with the system. Use cases describe the sequence of actions that provide measurable value to these actors. The system boundary defines the scope of the system, and relationships show interactions between use cases and actors. The steps to building a use case model are methodical. Start by identifying the actors, then list the main functionalities as seen by these actors to identify use cases. For each use case, define the normal course of events along with alternative paths, which we refer to as scenarios. Establish relationships between use cases and actors, then represent all these components visually in a use case diagram. Finally, document each use case in detail, listing the actors involved, preconditions, postconditions, main flow, and extensions. Now, let's talk about best practices in use case modeling. The first rule of thumb is to focus on user interactions. Concentrate on actions that deliver value to the user, steering clear of system design details. Secondly, keep it understandable. Use case diagrams and descriptions should be simple enough for stakeholders to understand without technical jargon. And lastly, embrace iterative refinement. Use cases should be continually refined and updated as new information is discovered and project requirements evolve. By mastering use case modeling, you equip yourself with an invaluable tool for understanding and designing complex systems from the user's perspective. It's not only about gathering requirements, but also about structuring interactions that pave the way for a system that truly meets the needs of its users. Remember, a well-crafted use case model is a cornerstone of effective system design.